cosine.
Okay, say that again. So here's the problem. What's the problem?
The problem is the limit of x that goes to 0, and then on the numerator is sine of 13x minus 13x cosine of 13x. And then in the denominator says 13x minus sine of 13x.
Like that?
Yeah.
Okay, so oh, this is different. Okay, so what happens when you put in, so this is exactly the way it's written?
Yeah.
Okay,
Well,
so
I mean, 13x for the sine and cosines. They're like in parentheses, but yeah.
okay. All right, what happens when you put in 0? What do you get? What's the
When I,
sign? What's the sign of 0? So it's 13 times 0, right?
yeah.
What's the sign of 0?
Sine of 0 is just, is it just 0?
Good. Minus 13. The cosine of 0 is what?
Cosine of 0 is 1.
Okay, and then that's over top of 13 times 0 is
0.
okay, and then the sine of 0 is
Just 1. Oh, no, 0. Sorry.
0. So this is negative 13 over 0. So that's basically negative infinity. It goes to infinity because anything divided by 0 is infinity. So this one, if you're telling me the problem is exactly like this, then I can't even use L'Hopital's rule on it. There's no way I'm going to get, remember, L'Hopital's rule only applied to 0 over 0, infinity over infinity, infinity minus infinity, and then 0 times infinity, and then 1 to the infinity, 0 to the infinity, or infinity to the 0. So this doesn't fit right here. When you get to this stage, it doesn't fit in any of those rules. So I can't use L'Hopital's rule on that.
Okay. Well, that's weird because when I went through it and I actually used the L'Hopital's rule, I went through it and I ended up getting 2. I got the right answer, but like,
are you sure you gave it to me correctly?
Yeah. No, I told you that the 13x is in the parentheses. I'm not sure that makes a really big of a difference, but the way you have it written is the same way.
You mean like that?
Yeah, like that, yeah.
Shouldn't matter because this is still 0 minus 13 over 0 minus 0. So you can't use L'Hopital's rule on this. Now, if there was an x in front of this, is there x? Is there 13x cosine?
No, it's actually not.
So if it was the limit as x approaches 0 of the sine of x, sine of 13x, minus 13x, the cosine of 13x, divided by 13x minus the sine of 13x. Then this now is 0 over 0. And this one I can use L'Hopital's rule on.
But you know what? Yeah, I'm sorry, dude. That's my fault. There was an x in front of that, the 13 in the numerator, next to the cosine. Yeah, the one in the bottom of that.
Okay, now I can do L'Hopital's rule.
Yeah.
And the other one didn't have an x. So that,
yeah,
x,
that
x right here that's missing,
yeah.
Okay, so now I can use L'Hopital's rule. Okay, so now we take the derivative. So the derivative of the sine of 13x is the cosine of 13x. But a 13 is going to pop out from the chain rule, right?
Yeah.
Then the next one is going to be the first let's use 13x times the derivative of the second, which is going to be the derivative of the cosine of 13x is going to be minus the sine of 13x. And then 13 is going to pop out. And then I'm going to have plus the first, which plus the derivative. Wait a minute, what did I do? I did the first 13x times the derivative of the second, plus the derivative of the first, which is 13 times the second, which is the cosine of 13x. And then over the denominator, derivative of 13x is 13. And the derivative of sine of 13x, you want to give it to me again?
It's just 13 times cosine of 13x.
Okay. So let's simplify. So I have 13 cosine x, cosine 13x, I apologize. I'm hungry. Okay. Then this one's going to give me minus negative. I'm going to get 13 times 13, which I believe is 169. So I'm going to get plus 169, the sine of 13x, minus 13, the cosine of 13x, all over 13 minus the cosine of 13x. So now, does something cancel, Mikhail?
Is it the cosine of 13x that cancels out?
Yes, so this divides out with that. So now I get the limit as x approaches 0 of 169. There's a 13 missing right here. Okay, times the sine of 13x divided by 13 times 1 minus the cosine of 13x. And that gives you 0 over 0 again. You see that?
Yeah.
Did you get that part?
Yeah. I had to do it twice. Yeah.
Okay, so then these divide out and just give you 13. Okay, so now you get the derivative of the top. So what's the derivative of the top?
The derivative of the top should just be sine 13x plus 13x cosine of 13x.
Are you doing the derivative of the top? Was there an
Yeah.
x that I missed? Did I miss an x? I did. There's an
Yeah.
x.
Yeah, there's supposed to be x, yeah.
Okay, I missed an x. That x is, again, that x is real important. Okay, so now take your derivative, and what do you get in the numerator?
In the numerator, I got sine of 13x plus 13x cosine of 13x.
Okay, so you're missing some 13s here. So you still, this 13 is still there. That multiplies the whole thing, right?
Mm-hmm.
Okay, so did you, so what did you do? You kept the 13x with the beginning or the top? You said this was, you had 13x, the sine of 13x, right?
Yeah.
Can you do your derivative, please? Did you count this, do it like that? This is one function and this is another?
I think so, yeah.
Okay, so let me see your derivative.
For my derivative for the numerator?
Yes.
For the numerator, it was sine of 13x plus 13x times the cosine of 13x.
Okay, so that's what I'm saying. You got the sine of 13x, right? Where did that
Yeah.
come from? That came from taking the derivative of x, right?
Yeah.
Okay, so you still have a 13 out here. Okay, sine of, so that's x times the derivative. So you took the derivative of x times the sine of 13x plus x times the derivative of sine x, right?
Yeah.
So that's another 13 cosine 13x. Okay.
And then in the denominator, I just got sine of 13x.
There's still a 13 there.
Let me see.
You took a, we had to take another derivative.
No, I just took the derivative of what we got for the
Yeah,
for the
but you
last.
get ready to get 0 over 0 again.
Let me see. No, in the denominator, I just had sine of 13x. I didn't have a 13 in front of the
Okay, so this 13 came from the 13 up here. Remember, it was 13 minus 13 cosine 13x. So when we took the derivative of 13x minus sine 13x, we got 13 minus, brought the 13 out, cosine 13x, right?
Yeah.
So that was in the denominator. So there's still a 13. So you still had a 13. So the 13 is still there. But it's going to cancel now. So the 13 is going to cancel. And we got to do one more derivative. So derivative of the first, what do you get for the derivative of the numerator?
For the derivative of the numerator, I had 2 times cosine of 13x.
Whoa, where did 2 come from? Oh, okay. I know. Well, you got sine. So I know where it came from. You got cosine 13x. That's the derivative of this times 13
Yeah.
plus first x times derivative of the second, which is minus 13 the cosine, the minus 13 the sine of 13x.
Yeah.
Plus the derivative of the first, which is 1, times the second, which is 13x cosine of 13x, divided by 13 the sine, cosine of 13x. Okay. So that's the limit as x approaches 0. So now you have 2 of them, right? Which is 26 cosine of 13x minus 13x the sine of 13x all over 13
Yeah.
the cosine of 13x. And that limit is?
And then I just simplified it and I got 2 over 1 once you simplify it, and which is just 2. I got 2 for that.
That's right.
Yeah, that one had a lot of, like, since you had to go through the allowances rule twice, they had a lot of steps. So
you did. You got 0 over 0 there. Then you got 0 over 0 here. So yeah, you got 0 over 0 here. And then 0 over 0 again. So that's what I was saying to you about that. Oops, that first problem. That first problem, I could tell because it was missing an X. It wasn't a L'Hopital's rule problem.
Yeah.
Yeah. Okay. Yeah, that's a good problem. Make sure you can do the subtraction ones and the power ones. The limit. Something like that. So that becomes 1 to the infinity. So how do you do that one? This is the one where you have to take the log. And then take the limit. Get some number L. And then your answer is e to the L. So this is the one where you have to take the log first, then simplify, then do the limit. And then you get that one. And then the other one where you subtract infinity minus infinity, that's another one where you have to find a common denominator. So make sure you know how to do those. Don't just take an L on that. Make sure you know how to do it. Other questions? Let's do this problem. The limit x goes to infinity of 1 plus 2 over x to the infinity power. Well, 2 over x goes to 0, so that goes to 1 to the infinity. So I have to fix it. So now take the log of 1 plus 2 over x to the infinity power. Oh, that should be to the x power. I can bring the x down and get the natural log of 1 plus 2 over x. Now, so I simplified it. So now I take the limit as x goes to infinity of x times the natural log of 1 plus 2 over x. And when I do that, I get infinity times 0. And that's another problem. It's another one of them L'Hopital rules things that doesn't work for me. So multiplying by x is the same as dividing by 1 over x. So I can change this to the limit as x approaches 0 of the natural log of 1 plus 2 over x. And then, like I said, dividing by x is this, multiplying by x is the same as dividing by 1 over x. So now when I take that limit, I get infinity over infinity. And finally, I am able to use L'Hopital's rule because I've simplified, I've rewritten it. Okay. So L'Hopital's rule now says take the derivative. So this is going to be the limit as x approaches 0. The derivative of the log says put that in the denominator, 1 plus 2 over x, and then multiply by its derivative. So when I multiply by the derivative, I'm going to get negative 2 over x squared. And then I take the derivative of the bottom, which is going to give me minus 1 over x squared. So now I can simplify this. This becomes the limit as x approaches infinity. I have a 2 over 1 plus 2 over x, because the 1 over x squared and the 1 over x squared divide out, the minus and the minus are gone, and it only leaves a 2. Okay, so now when I take this limit, I get 2 over 1 plus 0, which is 2. So that I very nicely call L. So therefore, if you remember the therefore dots, the limit as x approaches infinity, oh, this is infinity, this is infinity. x approaches infinity of the original problem, 1 plus 2 over x to the x has to be e to the L. So this answer is e squared. And I'm done. Here's a good use substitution problem.
Can we do another one like this first, please?
Say that again.
Can you do another problem like what we just did?
Another problem like we just did. If I take that limit is 0 to the 0 power. That's not what I want. What were the terms, the ones that I gave you? I can make this go to the 1 over x. So now it's 0 to the infinity. All right, so I take the natural log, 1 minus cosine x to the 1 over x. That becomes 1 over x times the natural log of 1 minus cosine x. So therefore, I get the limit as x approaches 0 of 1 over x times the natural log of 1 minus the cosine of x, which I can write as the limit as x approaches 0 of 1 minus the cosine of x over x. And so we did this one. Uh-oh, we didn't do this one. This has a log. Oh, something's wrong. I don't think that one's, I think I made up a problem that's not doable. Let me look for one in this book real quick. I don't like that one. What is wrong with this problem? Why don't I like it? Okay, what's bothering me is as x approaches 0, cosine x approaches 1. So end up with the log of 0, which you can't take. So this one's not going to work. That's what happens when you make up problems. That one doesn't work. I need to get one from the book that I know works. So here's one. You want one just like kind of like that. X to the, all right, the limit is x approaches infinity. I can do this one of x to the 1 over x, 1 over the log of x. Okay, we can do that one. So if I put in infinity, I get infinity. The log of infinity is infinity. 1 over infinity is 0. So that's of the right form. So take the natural log of it. So I get the natural log of x to the 1 over natural log of x. This one's a nice one. This is easy, actually. And then by the power rule for log of something to the r says bring that down. So this becomes 1 over the natural log of x times the natural log of x. So now I do the limit as x approaches infinity of 1 over of the natural log of x over the natural log of x, but that limit is just 1. So that becomes my L. So my answer is e to the L, or e to the 1, which is just e. Yeah, that one was an easy one. I should have given you that one on the test. Okay, any questions? Y'all gotta have more questions. I just don't understand. I'm trying to reach the front office. Yes, logarithmic differentiation is on the test. Using logarithmic differentiation. Okay, what do I do? So here, y is equal to this thing, e to the 2x times, I'm going to rewrite it as x plus 1 to the 1/2 power divided by x cubed minus 1 to the 1/3 power. All right, so now what do I do if I want to use logarithmic differentiation?
Quotient rule.
Oh, that will not get you any points on the test. I'm sorry. The reason why is because I want you to use logarithmic differentiation. So if you use the quotient rule, you are going to see this. If you do the quotient rule, you will see on your test, and then you will see -10. And then I will highlight that this is the rule I want you to use.
So it'll be the ln.
Yep, you gotta start with the ln. Okay, so because it's logarithmic differentiation, so you gotta start by taking the log of that thing. So you'll take the log of y, will be the natural log of that, e to the 2x. Whoa. Times x plus 1 to the 1/2 power and divided by x cubed minus 1 to the 1/3 power. Now you have to use properties of logs to simplify that. Okay, so you get the natural log of y. It's going to be the natural log of e to the 2x plus the natural log of x plus 1 to the 1/2 power. And because that's in the denominator, you're going to get minus the natural log of x cubed minus 1 to the 1/3 power. Now you have to simplify. So when you simplify, what do you get?
You simplify, you get, is it is it 2 ln e 2x for the first one?
Yes, but it's actually easier than that. Whenever you take the natural log of e to the something, you just get that thing.
Oh yeah, e to
Okay.
2x.
So this one just, yep, natural log of y. This just gives you e to the 2x. And then what do I do? How do I simplify the next one?
The next one would be, would that be like the chain rule?
No, no chain rule. I'm just simplifying. I'm not taking a derivative yet. So logarithm property says bring that 1/2 down.
That's
Then
1/2 ln.
of x plus 1 minus 1/3 the natural log of x cubed minus 1. Okay, so now you simplify. So now that it's simplified, you can take the derivative. So this becomes 1 over y times dy dx. And this side becomes what? How do I take the derivative of this side?
Oh, so now would you do the e to the 2x times 2?
Yep. Oh, no, this has no e anymore. I'm sorry. This is just 2x. Remember, the natural log of e to the 2x is just 2x. So the derivative of that is just 2. Okay. Then the derivative of the next piece.
Oh, the derivative of the next piece is, it's half. Wait,
That's right, 1/2. And
yeah,
then you
1/2.
have to do the natural log of this. Whoever wants me to post a video, it'll be posted. I think that was Malcolm. You're going to get x plus 1 in the denominator and 1 in the top.
Yeah.
This one, you get 1/3. You're going to get x cubed minus 1, but you have to get 3x squared in the top. So now dy dx says take that whole thing, which is 2 plus 1 over 2 times x plus 1 minus x squared over x cubed minus 1 and multiply that whole thing by y. And so you just put the original y back in. So now I get dy dx is 2, 1 over 2 times x squared plus x plus 1 minus x squared divided by x cubed minus 1 times y, which was e to the 2x x plus 1 to the 1/2 power. And then you have to divide by x cubed plus 1 to the 1/3 power. And that's it.
Where did you get the x cubed plus 1 from? I thought there was x cubed minus 1.
Because it's x cubed minus 1. It is x cubed minus 1.
Oh, okay. Thank you.
Thank you. That was a big mistake, but I appreciate that. Okay. Any questions?
What was the row number again where the test is going to be at?
Science Center 340.
Thank you.
You're welcome.
Hello, Dr. Locke.
Yes.
The last problem, so the derivative would be the it was the original equation times the derived
Right.
version.
Because
Okay.
we had 1 over y over here. Remember, the derivative of log y, and the derivative of log x is 1 over x. The derivative of log of anything else is 1 over that thing and its derivative. So the derivative of y, log y, is 1 over y dy dx.
Okay. All right, thank you.
You're welcome. So we multiply